In this video we will continue the discussion of macros we started in the previous one. Last time we have seen what are macros. Today we will go on comparing macros and functions. We have seen that when is a macro. But is it really required to be a macro? Could we get the same functionality using just functions? To be fair, we could. Let's define our own when, which is a function. It is fine if the condition is evaluated before the function is run, but we cannot pass directly the statements that we want to execute because they will have to be executed only if the condition holds. We can solve this problem taking as a parameter a function with the steps that one will have to run if the condition holds. Inside the body of our when, we call the function only if the condition holds. Inside trueFn, we have a reference to a function. We can call it using funcall. When we use this function, we have to put the body of the when in a function, for example using a lambda. As we can see, the result is what we expected. If the goal is removing the program we have to use with the if, this solution is not the best one, because we have to use a lambda instead. But we have shown that even without macros, we can prevent the execution of some arguments. We have also shown the function funcall that let us call a function when we only have a reference to it, not the symbol itself. It's interesting that funcall can be used only with function, not with macros, because they are not a function. Let's make an example. We define a function foo_f that returns the number 42. Then we define a macro that builds the same expression 42. We compile them and we try to call them with funcall. In this case, we have the symbol itself, not a reference to a function, but we can build a reference using the sharp quote. Sharp quote make a symbol callable. As we can see with the function it works, but if we call the macro, it returns as an error that foo_m is a macro, not a function. We can conclude that most of the time that we need macros, we could use functions instead. Now the question is, when should we use macros? And the answer is rarely, especially at the beginning. Let's make some examples on when they are useful. In the case of when, macros really make the syntax easier, thus it's a good choice to use macros. Another example is for performance reasons. Macros are expanded at compile time, or at most the first time that they are executed. Thus, one could use this fact to improve performance. I think about a web server that wants to produce HTML based on a Lisp form. One wants to create the HTML string one time at the beginning and then just return it. The macros we have written until now directly return an expression. But inside the macro we are writing a lisp program, so we could do whatever we want. Let's try to write a macro that does some more computation than just returning an expression. For example, we can write myEnd that returns nil if all the arguments are nil. Otherwise, it returns the first argument which is not nil. MyEnd of a single expression is the expression itself. In fact, if a is nil, it is evaluated to nil, and if it is different than nil, it is evaluated to its value. MyEnd of two argument is the same as if the argument is different from nil, return the argument itself. Otherwise, return b. Or, to be more precise, we have to return myEnd of b. This way, we can generalize to more than two arguments. Let's try to write it. We define a macro, myEnd, which takes a list of expressions. Then we check if we have just one expression, then we return the expression itself. Otherwise, we build a list in which we verify if the first expression is different from nil, return it. Otherwise, we expand the macro itself on the rest of the arguments. Let's try to run it. If we call myEnd on a singular argument different from nil, it returns the argument itself. And even if it is nil, the value is nil. Now let's try to call it on two arguments. In this case, we can verify that it returns the argument itself, because it is different from nil. But if the first argument is nil, it returns the second one. Because it checked that this is nil, so I have to call myEnd on the expression with just the two. All the code that we write to build an expression, in this case, for example, the if length of expression is equal to 1, we call it the expander code, will only be executed at compile time. Thus, it will not affect the execution time of our program. The execution time will only depend on the performance of the expanded code. For example, in this case, calling length in a recursive function every time is not an efficient way of solving this problem, because we have always to traverse all the expression, but this is only executed at compile time, so in this case it is fine. For today this is all. Let me know in the comments if you liked the video, leave a like and subscribe. Bye!